So what are we doing today? Well, I'm down at my magic cupboard, which is a little messy, but it's got lots of wiring in it. And we're going to do a complete overhaul here. So what this cupboard is there's a big battery in here. It's connected to some solar panels on the roof, 12-volt ones, and we have all the associated electronics, including isolation switches and circuit breakers and fuses and battery charger and blown up solar regulators, and also the network switch here running off 12 volts. So we are going to be upgrading this and doubling the battery capacity and replacing one of these things with one of those. So I blow up about 2 of these each summer because the solar panel current reaches a little bit too high for that little regulator. So yeah, we're going to be going to this. Alright, so my financial manager's on World of Warcraft right now, and we're running through this hub in here, or network switch. And so I'm just about to disconnect everything. I'm going to start by turning off the outdoor light, and we're going to hit both these isolation switches. But I've just switched my financial manager over to Wi-Fi, so there shouldn't be a problem. But I think my UPS is feeding back into the system here. Of course, now I've disconnected power. One end of my doorbell beam's not working, and the doorbell's going off continuously. Better go to shut that down. Alright, so that's the doorbell scenario figured out, and the UPS is unplugged. I should have done that first. And financial manager's over on Wi-Fi now, so we're just bypassing all of this. So now we need to start stripping out all the unnecessary stuff. Let's get cracking for that. Alright, so initially I put this in here in a hurry a few years ago now, because we needed a 12-volt system very quickly. So let's actually pull these keys out. And also all the network gets routed through here as well. And we've got this backup, the battery charger in here on top of that. Everything's a tangled mess, and it's starting to get hard to identify what is where in here. So it's all, yeah, this is what happens when you do stuff in a hurry. You end up with chaos. Now, some of these network cables are actually redundant too. Some of them have failed. I've got a bad batch of network cable. Oh, this is our outdoor light wire, that's what that is. And we've got other stuff that's been tucked away in here for years and not used. So we can strip out all of that. Oh, that goes to the kitchen lights. Yep, I probably should get in here with a label maker. Would probably be sensible. Now that network switch is way up the back there. In fact, I think it can stay there. Let's have a look over here. There's my network switch up here. I might put the solar regulator up on the back there. At present, this was changed in a hurry like 1.5 years ago and just got left hanging on the cables. So we might move all that up and out of the way. These isolation switches I left right at the front aren't going to reach, so we might move them to suit the regulator as well. I've got a fuse box here. This is all screwed down, so I might leave all that where it is. And we have a big circuit breaker as well. I guess we'll find out how things are going to fit when we pull this battery out, which slides out a bit like that, but it's going to be interesting because the next two, there isn't enough space to fit them in side by side. We're going to have to put it in one at a time. And that may mean lifting this shelf up out of the way to get them in. So yeah, let's pull things out even further. Alright, so I'm going to take my good Barco set of ratchet spanners here and find one that fits those terminals. And these have 4 different sizes per spanner, and they're all ratchety ones. I think the 14, well, I think it's a 13 mil for these. Should be a 13 somewhere. What are we, 12, 15, 13. No, these are a 14, all right. 14 mil. We'll pop these terminals off. Now this is a 130 amp hour battery. This one's about 4 or 5 years old. So we certainly can't just match another one to this because the internal resistance would be different and one battery would not be kind to the other. Right, that was our 14, was that in? Handy little things, these ratchet spanners. Alright. Alright. So it's our old battery out. Let's clear some space here. And these are not light batteries. Alright. It's about 30 or 40 kilos of battery. Right, now we need to clean everything else up, and I'm going to try and get this top shelf out, so we'll be back. Alright, so the top shelf has been lifted out and is out here, but stuff is still attached, obviously. But that just allows us to get to the top of both batteries and get them in without having to worry about the parking space of squeezing them through this doorway. I did measure to make sure they'll fit. So I have one battery in, and I almost forgot a step. I should check the voltage between both of these. And normally I should check the internal resistance, but I'll be running both of these batteries in parallel here. So I need to check my volts. So we're looking, let's see if we can get this on camera here. So you're looking at 12.47 volts for that one. Let's see what the other one's like. Get right in the corner here. And 12.46 volts. So close that I'm not too worried. Normally if there's a big disparity in voltage, when you hook them up in parallel, there's going to be a rather unregulated, very large amount of current flowing between the two batteries for a little bit, and that can cause damage to them, or if the internal resistance is different. So with neither of things is a good idea. It's awkward on the ground, and these are heavy batteries, so I'm going to do this next bit off camera. We'll shove the two batteries in beside each other and see if they fit. Hope I don't need a run up here. Alright, so they're a bit of a tight squeeze in here. I could make some adult rated joke about an ex-girlfriend, but we won't do that. So now I've got to get this top shelf in. I'm going to take a breather because there's about 100 kilos of batteries in there. Actually, you know what? I'm guessing at that weight. Let me check the side of the box. Alright, so they are... Well, the box weighs half a kilo apparently. Doesn't feel like it. But yeah, 34 kilos a piece. So there's 68 kilograms of battery in that lot. Alright. And I've got some dead monitors to get rid of too. So let's continue on with the decluttering of the battery cabinet. Now I'm going to take my handy dandy Ryobi. I'm going to remove all these square drive screws. I'm going to strip everything off here. I'm going to rearrange it from scratch as best I can. Hopefully without disturbing too many of the existing connections. Alright, so let's do a quick little thing here and click our fingers, or I can't click my fingers, they're too clean from washing them so much. I've got no grip left. So let's just cut to the next video where these have been removed. We've got everything detached from the shelf board, which is now laying in the hallway over here. So next job is to get in here and attach link cables, and hopefully we're not going to cause any crazy massive arc. So let's get that sorted. I'm going to connect the batteries up first here. Now, the first thing I've done here is I have taken the 60 amp breaker, which is the main feed to everything, and I've put this breaker open circuit. That means all the exposed contacts and everything will be sorted. I'm going to put that in a suitable position before I do anything else, so it's well out of the way, and so I don't have any accidents. The next thing I've done is I've taken the 12 volt solar input. There's about a couple of 100 watts of solar panels up there. I've taken the ground wire and taped that back onto the cable so it doesn't get into anything it shouldn't. Hot wire is through here to our regulator. I'm going to isolate that in a moment too, but it just helps me identify what things are before I disconnect all the power supplies to it. Then I'll worry about all the rest of this. So let's get all this disconnected properly. A quick note before I tighten up the nuts and bolts here. I'm picking up my hot wire off one battery, my cold wire or my negative or my ground off the other battery. And what that means is that the path to both terminals is of equal resistance, so that I'm not if there's any kind of resistance through these cables here, it's balanced on both sides. I'm not draining one battery any faster than the others. So now it's time to get in here with a ratchet spanner and tighten all these up. It's a bit of a tight spot in here, but we'll see how we go. I'm being very careful not to touch another terminal with a spanner, and crucially I'm using one that's short enough that can't touch an opposing pole, because across that way they're both negative terminals. And so it makes it a little harder to weld your spanner to the socket. There's not much room in here for camera, hand, spanner and my head. Oh, that one's got a bit to go. Where's my 14? There it is. It's almost not quite tight enough to ratchet. There we go. Oh. And see, it would be pretty easy here to touch two terminals with a spanner, and that's why I've done it this way, so that that doesn't present a hazard. There's a couple down the back here that you can't see. Let's bring our camera around a bit over this side. Here we are, 14. I'm taking care to not over tighten these things. I don't want to bust anything, but they are quite firm. They're not going anywhere. And I've used spring washers on the top as was supplied. So now we've got batteries hooked up. I'm going to check my voltage just to be sure, and then we're going to move on. So the next step, putting the shelf back in. Let's see if we can get that in. Right, shelf's in. Now I think I need to move the camera because it's sitting on top of my charge controller box. So we'll be back. Now, here's some time for comparison. This is the charge controller I was using. Apparently it's a 20 amp controller. Now I have about 200 watts worth of panel. So usually during summer I burn out one or two of these when the sun gets really bright. So I think the 20 amp might be a bit of an optimistic rating. These are worth about $6 to $8 each. This guy's worth about 350, but it's an MPPT controller, which means I can take good advantage of the lower sun through winter as well. So it's going to be a nightmare to program. I haven't really read the manual fully yet, so I'm going to have to figure that out. But I want to get it connected first. So let's get this little cover off, and we'll get our battery hooked up to this first and get that bit of it safe. And have a bit of a look through it. I'm pretty sure the instructions said connect the battery before the solar panel. So that's what I'm going to do. Interestingly, rather than using a Phillips for the door, they're using a flat blade, which I think is some kind of electrical standard. I probably need to look that up, but I do find with critical stuff like this, there's usually a flat blade screw on it. Usually with mains like power meters and stuff. Oh, it's a hinged door. That seems interesting. Alright, so we have our screw terminals in here, and they seem to be good enough to accommodate a decent cable. So we'll get them in and we'll be right back. Before I do that, one thing I should probably note. This wire here is coming from the batteries, and this is going off to my distribution board. This is going off to the solar regulator. Now, I'm not actually planning on using the load controlled output on this. Because I run that through my workbench and stuff, and I may occasionally short circuit it, so I don't want to blow up the regulator side here. But for constant loads, I'll probably set up another bus bar off that so that the constant loads don't kill everything. So alright, yep, I think I'm going to hook these in. Moment of truth, I'm going to hook the batteries up, and this does have a reverse polarity protection, so let's turn this on and see what happens. And I've got major circuit breaker So let's turn you on. Actually, before we do, just make sure nothing's shorting out on the floor here. Move my spanner off the ground rail. Turn you on. 12.4 volts, that's not too bad. I registered before. All right, and okay, so there's no fault mode on here. That's good. So let's just turn off my isolation switch. Good, that's going to isolate it. Turn off our breaker. Let's get the panels hooked up. All right, so I've got the camera in a really precarious position, but let's just turn some things on for a start. Let's turn our batteries on. Now let's see if we can get solar on. See what will happen here. All right, so it's showing solar is connected and it's selected 12 volt mode. Let's turn our panels off for now. And all right, let's get everything else situated. We'll isolate everything. Let's put everything in the box. All right, so that's our regulator mounted up the back where I can easily read it with the door open. And it keeps it up off the floor. These things are a little bit harder to mount now because the cables are short, but we'll figure that out in a minute. I'll come up with a solution. I might stick another board in here and screw them down to that. But either way, we're moving. All right, I'm about at the capacity of what I can do kneeling down at the moment. My legs have been numb for about the last 20 minutes, but we have our 2 new batteries in here. We have our horrible cable management attempt here. I will be getting in and redoing all of these network cables sometime soon, and certainly I'll be redoing all these cables from scratch. But for now I needed to get the batteries updated, this in, and get this working, and then at a later date when I can get another outage here, because we do tend to depend on this. So next time there's another gap that we can use as an outage, we'll redo all this cable management. Anyway, we need to get our things connected, so let's hook up our main battery breaker. Let's turn batteries on. Okay, there's batteries. We'll let everything boot up. And now let's turn on solar and wait for the magic smoke. All right, what's our LCD saying? Yep, we'll give it a few moments to start charging. It takes a bit to boot up. I've got all my covers back on. Turn on our outdoor light. There's a motion sensor on that. This is our negative bus bar. This is our positive distribution, and it's got fuses and lights that show up when a fuse is blown. I needed these right at the front so I can add and subtract things easily. What's our charge controller saying at the moment? Has it started to catch up yet? Not yet. We'll give it a few minutes and see what happens. It's been a few minutes and I realized something I forgot. The temperature probe. This has got a terminal on it. I'm not sure if that's meant to attach to the battery or not, but I know that's an ambient temperature probe which affects the charge current. Now I'm seeing my voltage go down at the moment. I don't like that. I probably shouldn't be doing that. So yeah, we'll see what's happening in a minute. Alright, so I'll come back to my desk to have a bit of a read of the manual here. And battery voltage does continue to drop a little bit. If I turn my overhead lights off, it's about 12.4 back at the regulator. This is up at the other end of the house. It's showing 0 amps charge current. The batteries here don't seem to be rising in charge. But crucially, they don't seem to be really going flat either. So been a bit of a loss. This says that the minimum charge voltage is 16 volts, and we're hitting 16, 17 and sometimes 18 volts on the input under load, even though I don't think it's under load. So I'm not sure if it's actually trying to charge the battery. It says it's in bulk charge mode, which on the diagram here, bulk charge should be a constant current charge state. Maybe there's some more settings in here I've overlooked. I'm going to do a little bit more reading and find out, and I'll have some lunch at the same time. That usually clarifies things. Alright, as an experiment, I've hooked up the old solar charger just temporarily to see if my battery volts come up, trying to determine if that is the problem. And I've sent a message off to the seller, but it's a Saturday, so I won't hear back for a little bit. We'll probably have to see about this on Monday. So there's a bit of glare here at the moment because the sun's moving over the house a little bit. But we're looking at 12.3 volts at the moment. I've just set them over. We'll check back in probably about 10-15 minutes and see if we've come up at all. Alright, so while I've been waiting for the charge to come up, I decided to do a little bit of maths. Now on the roof here I have three 60-watt panels, although two of them are quite old. They were freebies off a caravan, and their output probably isn't great. So that leaves me with a theoretical maximum of 180 watts with about 11.25 amps. So I'm going to conservatively say that the current is probably a little below that, and probably about 8 amps, we'll say, is a safe assumption. Now I've gone from a 130 amp hour battery to a parallel pair totaling 270 amp hours. Now, charging at the full rate here, we would expect that to take about 14 hours to fully charge the 130 amp hour, which I've never run that completely flat. My daily use is usually met by about 11 or 12 o'clock around about this time of day, or time of year rather. So I'm going to obviously more than double that time to about 29 hours to see a fully charged battery. Now, interestingly enough, if we pan up to my regulator up here, or my voltage sensor up here, come on, focus, you can do the trick. You can see here I have come up to 12.4. Now I went and switched a few things on and off and everything like that, and it has recovered. I'd say there is current getting into the batteries. Some of the forums I've read online and whatnot have shown that these regulators might not actually show a charging current when they're actually charging. So I'm going to leave this go a little bit. I'm going to check one more thing. A handy dandy pan tilt zoom camera on my roof here that has a high zoom capability. One of the things it affords me is the ability to look at my panels without having to climb on the roof. Now, believe it or not, that little panel up the top there is a 60 watter, and these are both 60 watters as well. And they are kind of dirty. I might give them a hose down. We can go and have a good zoom in here and have a look at exactly how dirty they are. So, lots of dust and crap on those panels. They might not be outputting a lot of current right now. Definitely these guys. So, I think I'm going to get my ladder out and a hose and give them a spray down and see what happens. Right, so I just had a fight with the hose and busted a hose fitting off and got soaking wet. But we can see here our panels are looking much cleaner when focus comes back in. Much cleaner. I'll have a look at this other guy over here. There's some scratches and permanent marks up here. I think the birds have been crapping on it. With the MS and my ability to walk being a little limited at the moment, I try and limit how much I get on the roof. And as you'll see up here, I just stuck a ladder in and I didn't actually crawl on the roof. I just hosed it from a distance. So that'll be good. And I can check the shadows here off the roof. It won't be too much longer, and the shadow here will extend across these panels. I don't have too much more time to charge these panels. Or at least, anyway, charging the batteries is the word I was looking for. Now this has dropped from 12.4 back to 12.3, but I just walked past the kitchen, which turns on a motion sensing light. So there will be a slight drain in there. I'm just going to leave this go with the standard charger on here till the end of the day and see what the volts are at the end of the day, see if it puts anything on there. But based on this, this could be 3 or 4 days before I actually see it come up to charge. So that charger could quite well be doing its job, but I don't know at this stage. So we're going to let it all go for a few days on the old charger, and till it comes up to volts, and then we'll swap over to the other one again and see what happens. So yeah, and there's a whole bunch going on. I've got to go in for like a 2-hour long MRI on Monday, which is 2 days away from now, and that's going to pretty well knock me out of the stuff, and that takes quite a bit of time and energy to do that, especially considering I'm now like a couple of kilograms over the weight limit for the MRI here. So they're not going to put me through the machine in my local town. I've got to go to the next one over, and during quarantine times and and it'll be late at night, and so it's just a long process. So I think by the time I'm through all of that, we should be right. And we've seen a little flick here. That would have been that motion sensing light has just turned off again. So now it's starting to recover the charge a little bit. There we go. See a little flick. So I think it probably is charging. It's just I've doubled the battery capacity, and I'm used to seeing this bounce back much more quickly. So I think we'll just give it some time and see what happens. I think overnight what I might do tonight is I might put the actual battery charger, the mains battery charger, on it and let it all come up. But anyway, we'll talk more about this in the morning through the magic of video. The next clip you see will be the next day. We're back looking at battery volts, and I'm going to turn the overhead lights off for a minute. I gave the batteries overnight, I gave them 6 amps, and that would have been about 8 or 9 hours. They've been at 6 amps, and they've come up to 13.0. It was 13.4 on the charger this morning. I disconnected the charger and everything leveled out just before the sun came up, and that was at 13 flat, 13.0. Since the sun's come up, the voltage has popped up to 13.5. So that means my old charger is doing its job. So I think it's time that I swapped everything over to the MPPT charger and see what it does. And obviously there's a bit of a voltage drop up this end, so that when I turn these lights on, it's putting a bit of load on that cable. So let's go and swap some stuff over. All right, well, we've got it connected back up again and showing at 12.7 volts. So let's hook up our solar panels, turn them on, see what happens. So now we're showing 12.7. Let's see if we can see charge current. Now we're showing charge current. All right, so we're showing about 6.8 amps, which is about normal. So we're looking good. We'll go try up the other end. Well, that pretty well wraps this video up. So yeah, the batteries are in, solar panels are charging. I've ordered myself a new 300 watt solar panel because these ones have been up here for about sort of 5 or 6 years, and they were old when they were put up there. So I think that 6 or 7 amps output is probably correct, and that probably only just keeps up with what I'm using. So I think for the winter months I'm going to put a bigger panel up. But that'll be another video. So we'll see you all next time, guys. And I hope it's been an interesting one. And yes, I will be getting in there and cleaning up those cables.